So for number 1, you could see that's arithmetic. I'm adding 3 each time. And in order to write the sigma notation, I need to know what n equals right here. I need to know this value. For 13, I don't know, so I'm going to have to do the explicit formula. And here it is right here. And then I simplified it, and this is what you get. So I'm going to replace f of n with 13 to solve for n. So I'm going to add 5. And so it's 18 equals 3n, divide by 3. So 6 equals n. So this is the 6th number right here. So when you write it in sigma notation, you would say like this, n equals 1 to 6 for negative 5 plus 3n. So for number 3 is very similar to number 1. It's arithmetic. The common difference is positive 2. And I need the explicit formula or explicit rule to find what n, what this n value is right here. So I'm going to replace the f of n with 21 to solve for n. Add 3, you get 24. Divide by 2, you get n is 12. So when you write it in sigma notation, it'd be n equals 1 to 12, because it's 12 terms. This is 12 right here. And the formula would be negative 3 plus 2n. And for the first few, for number 5, the common difference is negative 1/3. If you add negative 1/3 to each term, you get the next term. And just like the other two, we're looking for the value of n for negative 7/3. So I wrote up the explicit formula or explicit rule, distribute the negative 1/3, and then here I combine these two to get 15/3, which is actually 5. So now I'm going to replace f of n with negative 7/3, and I should probably just keep it in as 15/3, that way it's easy to add by thirds. So I'm going to do negative 15/3 to both sides. Okay, so then I get negative 22/3 equals negative 1/3 n. So I'm going to multiply both sides by negative 3. By negative 3. So right here this cancels, and here this cancels, and the negative times the negative is positive, so n is 22. So right here is a 22. So in sigma notation, n is 1, and this is 22 for, you could keep it as a reduced number like this, and that's it. And I was saying before in the other one, they're not asking for the sum, they're just asking you for the series in sigma notation. So number 7 is geometric, because I took 27 over 81, and the reason I knew it wasn't arithmetic is if you subtract, there's no way you're going to get a 1/3 at the end over here if you're subtracting whole numbers from here to here, right? So you can't get a third. The only way to get a third is if you divide. Like if you put the 27 over the 81, you get 1/3, and that's what you're multiplying by to get all the way over here. So it's geometric, and here's a formula, the explicit formula. So now I'm going to replace f of n with 1/3. Okay, so 1/3, because I want to know what n is. So 81, 1/3 to the n minus 1. So I'm going to divide by 81, and so that's going to be times 1 over 81, like that, times 1 over 81. Same thing on both sides. So over here it cancels, and so you have 243. So think of a number, let's see, 3, 4, maybe 3 to the 5th power. You know that 3 to the 5th power is 243. Just double check it real quick. 3 to the 3rd power, to the 5th power is 243. So with that in mind, I know that this here would have to be 5, right? Because 1/3 to the 5th power would give me 1 over 243, which is what I have on this side. So n minus 1 is 5, so that means n equals 6. Okay, so this up here is 6. So for sigma notation, you would write this, n equals 1 to 6, and the formula is 81 times 1/3 to the n minus 1. Oops, minus 1. Alright, so for number 9, I know it's not arithmetic because from 80 to 60 is minus 20, and from 60 to 45 is minus 15, so it's not arithmetic. So then I try putting 60 over 80, and I get 3/4, and then 45 over 60 is also 3/4, so it's geometric. So here's the explicit. Now notice there is no number right here, right? So that means the dot 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 means it goes on forever, so that means that n goes to infinity. So when you write it, you'd write n equals 1, and up here you would put infinity. And the explicit 80, 3/4 to the n minus 1, and close it. And that's it. Alright, so here we have an arithmetic series, and we know it's arithmetic because it says so in the instructions. And they want some of the first 14 numbers, and they gave you the first number right here, and they gave you the 14th number right here. So all I did is, and remember t sub 1 is the same as a sub 1. Okay, so don't get confused with the notation. It's the same thing. And I'm purposely doing this of finding stuff that has different notations, so just so you guys get used to it. That not everything is that there are other ways of writing it, not just the way the book writes it. So if n is 14, so 14 over 2 is 7. So this is going to give you 107 times 7, which is 749 for the sum. So I have t sub 1, it's right here, but I don't have t sub 40. So I wrote down the explicit formula, and I'm going to go ahead and find the 40th term. So I replace the n with 40, and that gives me 4 minus 80, which is negative 76. So right here I put 2 minus 76 times 20, so that's negative 74 times 20. So that's going to be negative 1480. Alright, for 15 they give you t sub 1 and t sub 3. And from there we need to find the sum of the first 40 numbers, right? Okay, so I know that t sub 1 is 1/8 and t sub 3 is 9/8. So there's a number in between them, right? Because there's a number t sub 2 in between 1/8 and 9/8. Well, the difference between these two is 1, 8/8. So that means that halfway would be 4/8. So if you add 4/8 right here, because that's half of 8/8, you end up with 5/8. And let's see, does it work for the next one? If you add 4/8, do you get 9/8? And the answer is yes. So my common difference is 4/8. And I know I could reduce it to a half, but I'm going to keep it as eighths just because this is an eighths. It might be easier to just keep it in eighths. So 1/8 plus 4/8 n minus 4/8. So that means f of n is 1 minus 4, negative 3/8 plus 4/8 n. And so my 40th number, so f of 40, because I need that for my sum, right? I need the last number on the list. Negative 3/8 plus 4/8 times 40. That's going to be, what is it, 20? 1/2 times 40, that's 20. So that's negative 3/8 plus 20. And so it's going to be 19 and 5/8. Right, that's what 20 minus 3/8 equals. So you go over here and you set up the equation. S sub 40 equals the first number, plus 5/8 times 40 divided by 2. So that's 1/8 and 5/8 is 6/8. So 19 and 6/8 or 3/4 times 20. 40 divided by 2. So I can change it to decimal. This is 19.75 times 20. And we get 395 as my sum. So for number 17, you're going from 1 to 12, and again, it doesn't always have to be n equals 1. So in this worksheet, you're going to see like a variety of variables, but it still means the same thing. Here's your explicit formula right here. Now I know it's arithmetic because it's 5 times r, and so it has the same form as a linear function, which is arithmetic. What else? I need the first number and the 12th number, so I use this to get the formula here to get the first number and the 12th number. So now I'm going to add them together, and so it's 5 plus 65 times 6. 12 over 2 is 6, so this is 65, 70 times 6, which is 420. So 19 is very similar to 17. It's arithmetic. Again, it has the same format as a linear function right here. It's a linear function, so we know that it's arithmetic. I found the first number and the last number, f of 1 and f of 15 right here. So I'm going to add 13 minus 15, and we're adding 15 together over 2, so this gives me negative 2 times 15 over 2, so remember it's 2 over 1, right? So then that means that the 2 and the 2 cancel, and the answer is negative 15. Okay, so I over 3 is linear function, and I rewrote it right here so you could see the common difference is going to be 1/3. Okay, so this is still arithmetic. So I'm using the formula for arithmetic series. So it's the first number plus the 9th number times 9 divided by 2. So this is going to be 3. I'm going to get a common denominator, which is 3. So 1/3 plus 9/3 is going to be 10/3 times 9/2. So I can reduce here. 3 goes into 3 once, and it goes into 9 3 times. 2 goes into 2 once and into 10 5 times. And so that's going to give me 5 times 3, 15. 1 times 1 is 1, so it's just 15. Remember, t sub 1 is my a sub 1. It's my first number. So the sum of the first 6 numbers in the geometric series, you set up with 1 minus 4 to the 6th over 1 minus 4. And so you need a calculator to get 4 to the 6th. So that would be... So that'd be 4,096, which you have right here. And then 1 minus that would be negative 4095, and then the bottom is negative 3. You divide it, and you get 1,365. So let me go through all this work. You set it up like this. This is the original equation, the original formula for the sum. 1/10 to the 5th power is 1 over 100,000, and then 1 minus 1/10 is 9/10. Okay, that's all I did here in this step. Then to this step, I got a common denominator, so 1 minus 1 over 100,000 is this right here, and again over 9/10. And then over here, when you divide by a fraction, you multiply by its reciprocal. So now I'm going to do is cancel any common factors. So 9 goes into 9 once, and it goes into here 11,111. And then I can reduce 3, 4, 2, 4 by 10. So it's 1,000 like that over 10. And you can leave it like that or change it to a mixed number. Okay, so I would just leave it like that. And if you divide it, you would get this. So either one of these is fine.